It is now my pleasure to introduce Ben Moore. Ben Moore is Professor of Astrophysics. He is author and he is a musician. He's the director of the Center for Theoretical Astrophysics and Cosmology at the University of Zurich. And besides many scholarly publications, he's also renowned for his popular books, such as Elephants in Space. He is a guitarist in the band Milk 67. He's speaking to us in a recording made during exams at the University of Zurich, and we're very grateful to have Ben Moore here as a guest of Engadine Art Talks. Thank you, Ben Moore.
I would like to tell you a short story about the past, present, and future of our moon. My story begins during the Cold War. The Americans and the Soviet Union, they entered a psychological war, a struggle between the ideals of communism and capitalism. And this struggle had been brewing for several decades following the end of the Second World War. The culmination of this was the space race. Both the Soviet Union and America had programs to land astronauts on the moon, to show and prove to the world who was the strongest. The Americans won this war. It was an incredible achievement. The Apollo program employed over 400,000 people who were working in 20,000 different companies and universities. Here is a video of Eugene Cernan on the moon. He was the last man on the moon, and this video is the only successful attempt at recording a departure from the lunar surface. In each of the Apollo programs they had tried to do this, but had failed. Here the astronauts had left a camera remotely from the lunar vehicle that would take them back to the orbiting space station that would bring them back to Earth. And the camera was not operated by someone on the moon. They hadn't left someone behind. The camera was operated remotely from Earth. Now the video here during the ascent from the moon shows the part of the descent vehicle that was left behind, and you could see some of the astronaut tracks on the moon. And now the camera is panning around since 1972, when Eugene Cernan and the two other astronauts left the moon. No one has yet been back. And that just shows how difficult it actually was to get to the moon, even though several space agencies, including NASA, private companies such as Elon Musk, are wanting to go back to the moon. They haven't accomplished that again. Just shows how difficult it is to actually land a human on the moon and bring them back. Now, those footprints and tracks on the moon and the descent vehicle, the part of it that was left behind that you saw in that last video, you can see here with a telescope. This is not a telescope from Earth. This image is taken by a satellite that is currently orbiting the moon, the Lunar Reconnaissance orbiting satellite. You can see the descent stage there and the tracks of the astronauts, their footprints, but you can also see those double-lined tracks in this image, and that is the tracks from the lunar rovers. 50 years ago on the moon, there were electric cars. Pretty impressive. Now, just as a little aside, we are used to seeing the moon in the night sky as this bright, silvery, white object. But what color really is the moon? if we take a range of shades from black to white, we might think the moon is very close to this silvery white color. It's not true. It's actually a dark gray color. It appears white to our eyes due to an optical illusion. When we see an object against a black background, the blackness of empty space, then our eyes emphasize the brightness of any objects we can see. The moon appears bright white to our eyes, but it's actually this dirty dark grey colour. And you can see that from this image here, which shows the real colour of the moon. It's a bit like the colour of a tarmac on the surface of a road. Now, getting astronauts onto the moon was the goal of the Apollo program, to show who was the strongest nation. But there was also some science carried out. The science wasn't the main goal, but the science that was achieved by the astronauts was quite remarkable, and it changed our whole understanding about our moon and how it formed. Here you see one of the astronauts is deploying an experiment. It's actually a seismometer. With this seismometer, scientists could measure how the moon vibrates when something hit it. During the Apollo mission, they deliberately crashed pieces of the spacecraft that they didn't need anymore, such as the rocket thrusters, onto the moon, and that impact caused the moon to vibrate like a bell. From those seismic sound waves that pass through the moon, scientists could determine what the moon was like inside, its structure, just like how we use earthquakes on Earth to measure the internal structure of the Earth. And this led to one of the first surprises. Here's a slice through our Earth and moon. Inside of our Earth, we have a giant metal core. It's about a third of the volume of our planet. But from the seismometers on the moon, we found that the iron core of the moon was just 2% of the size of the moon. That's a bit strange, and it's one of the main clues in understanding how our moon formed. The next clue came from the astronauts that were collecting moon rocks. Now, this wasn't always easy, as you see in this video. It's actually hard walking on the moon in this heavy astronaut gear, which was supplying oxygen and keeping the astronauts warm. But luckily, the gravity is so low that when they fell over, they could manage to push themselves back up again. But it was difficult. You wonder what it might be like if the moon was larger and the gravity was much stronger. Then if you fell over with these very heavy astronaut suits, then you might not be able to get up again. So the astronauts were collecting moon rocks, and they collected over 300 kilograms of moon rocks and brought them back to Earth. This is an image of one of those lunar rocks. Now, these lunar rocks, some of them were sent out to universities for analysis, and there are still a couple of 100 kilograms in this very secure vault, a lunar samples vault, in a secret location, very heavily guarded. Why is that? Well, it turns out that the moon rocks are incredibly valuable. In fact, they're about the most valuable thing by weight that exists on our planet. A couple of years ago, 0.2 grams of lunar rocks that were brought back from the moon were sold for almost $1 million. 0.2 grams. In this vault, there's over $300 billion worth of moon rocks at that price. What did we learn from these moon rocks? Well, the most surprising thing we learned was the composition of these rocks. If we look at the molecules within the moon rocks, more specifically the isotopes of molecules, it was found that the moon rocks were identical to the rocks on Earth. That was a huge surprise, because each of the planets is expected to have slightly different compositions in their rocks. And it was this discovery that led to a new theory for the origin of our moon. If the moon was made of the same material as our planet, then its formation must have been linked to the Earth. It must have once been part of the Earth. The new theory that was developed is that sometime in the past, about 4.5 billion years ago, a large object hit our Earth, an object the size of Mars, and this impact shattered material from the mantle of our planet into orbit around the early Earth, and that material coalesced and condensed to form our moon. In this model, the moon was therefore once a part of the Earth. This impact 4.5 billion years ago, that's the age of the moon. We know the age of the moon because we can measure the age by looking in detail at uranium in the lunar rocks that were brought back by the Apollo astronauts. This impact theory explains how the moon is so similar to our Earth, because it was once part of our Earth, but it also explains why the moon has such a small amount of iron, such a small iron core. And that's because this impact, it smashed material from the mantle of our Earth and not from the core where all the iron is. In the mantle, the exterior part of our planet, there's very little iron. And it's that material that went into orbit, into this disk, to form our moon, which explains that first discovery by the Apollo astronauts. Now we can simulate this collision in our supercomputers to look and see if it's correct. If we collide a planet the size of Mars with our Earth, we can look at the debris that forms around it, and we can follow that to see how potential moons can form. The theory is not perfect, and we're still working on the details, but some variant of this is thought to be the best picture, the best scenario for the formation of our moon 4.5 billion years ago in the past. Let's turn to the future. The third big discovery made by the Apollo astronauts was made because the astronauts left behind these mirrors on the surface of the moon. From Earth, we can shine a laser at the moon, and it will reflect from these mirrors, and we can time how long it takes for that light to get to the moon and back to the Earth. We can measure very accurately the distance to the moon. And what we have found is that the moon is moving away from the Earth by a few centimeters every year. If we look at an image of the Earth and Moon, you might be surprised to see just how far away the moon is from our Earth. If the Earth was a basketball, the moon would be about 7 meters away and the size of a tennis ball. Now, the moon is drifting away from the Earth today. That means in the past it was much closer. And that's what we expect. after the moon had formed from this giant impact, it would be just about 3 Earth radii away. And over time, the moon has drifted into its current position. Now, this was first understood by none other than George Darwin, son of Charles Darwin. George Darwin was a very talented astronomer, and he calculated how and why the moon was moving away from the Earth. And it's all about tides. Our moon squeezes our Earth into something like the shape of an egg. The gravity of the moon squeezes the Earth and stretches it. And this gives rise to tidal bulges, one at the front of the Earth facing the moon and one on the back of the Earth. As the Earth rotates, in 24 hours, anyone will pass through both of these tidal bulges. And it's these tidal bulges that give rise to the ocean tides, as the water moves up the bulges and falls back again. And this will happen twice in 24 hours, which is why there are 2 tides per day. Now, what George Darwin and actually Immanuel Kant before him had calculated was that there's a secondary effect, that the moon pulls back on these bulges, and this causes the Earth's rotation to slow down. Over time, Earth's day is getting longer and longer, and this has actually been measured with atomic clocks. Earth's day is lengthening. In the past, the length of our day wasn't 24 hours, it was just about 5 hours long. And it's slowly getting longer. As a byproduct of this lengthening of the day, the tides between the Earth and the moon cause the Earth and moon to be moving apart, or the moon to be drifting away from the Earth. It's quite a complicated idea to explain, but I try to do this at a level everyone can understand in my last book about the moon.
So there's a lot more you can read in these books too. It first published by Cernan in Zurich, Mond, eine biografie, and you can find it in English on Amazon, Moon, Past, Present and Future.
Another consequence of this intricate gravitational dance between the Earth and the moon is that it's not just the rotation of the Earth that's slowing down. The day is getting longer. It means our rotation speed is slowing. The same happens to the moon. If the moon was rotating in the past, these gravitational tides have caused the moon's rotation to slow down such that it is tidally locked. And it was George Darwin that first explained how and why we only see one side of the moon. It's tidally locked to the Earth. The moon rotates exactly once in one orbit. In fact, another discovery from the Apollo astronauts was flying around the moon and taking images like this of the so-called dark side of the moon. It's not dark, it's just that we can't see it from Earth. It receives as much sunlight as the near side of the moon. But the surprising thing was, this is the view that we are used to, but the view of the backside of the moon is quite different, not as heavily cratered. We don't know why that is. Still working on that. In the future, as the moon moves away from the Earth, at some point, about a few 100 million years from now, we will see the last total eclipse of the sun. The moon is moving away from Earth, its size on the sky is getting smaller, it won't be large enough to block the sunlight. So the eclipses of the sun will be looking more like this, these rings. In the far future, about 10 billion years from now, the moon will have moved so far from Earth, would have moved about 10 times further away. Earth's rotation will have slowed down to about 1 month long, so the night and day will last for 30 days, and the moon and Earth will be fully tidally locked. We will only see the moon from one side of the Earth. That's my story of the moon. Thank you.